So this is a problem in invariance, which is from the previous day's theme. Okay, the previous day's theme was numbers on a blackboard, and we were doing things on that. So what is the question? So we have the numbers 1, 2, 3, dot 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 till 20 written on the board, so it's already written. At each step, so this is writing it in front. So each step is pick any two numbers A and B, and replace by A plus B minus 1. Okay. The question is, what number is left in the end? Okay. So first, can someone give an explanation as to why the answer is what it is? With maybe you can tell the answer also with the. So first I want just the answer with maybe a rough explanation. Anyone can just do it because they've already done this earlier. Huh? Yeah. So some explanation, some short, some any explanation you can think of. So you have said something interesting. So last time we had not said this, that we are decreasing the sum by 1. Okay. Last time we were saying, okay, you take two numbers A and B among many of these numbers, and you replace this A and B, you remove A and B, and you replace it with A plus B minus 1. Okay. But and we were kind of saying that you do it in any way. I mean, at each step, you're adding two numbers, but then you're decreasing one. So in the end, you're adding up all the numbers, but you have done subtraction 19 times. That's a fine explanation. But if you want to just put it in the language of invariance, then the right way to say, maybe I'll just write this because this is a spot on phrase kind of, is that the sum is decreasing by 1 at each step. Okay, so the sum is by 1. That is the invariant, a kind of monovariant. That is what is. Okay, so we should think of it like this. So we should think of it like this, that initially, okay, so why is the table shaking so much? Because usually I place it on something else, and today that is not the case. So I have to place it somewhere once again. I mean, the table is not shaking, the laptop is shaking. Better. Okay. Yeah. So what I'm saying is, initially we are starting with this, but we must assign a parameter, and that parameter is just the sum. Yeah. You can just say S0. You don't have to say S0. Let's just keep it. Initially, this thing is this. Okay. Now, when you take two numbers, any two numbers, and you replace and you remove them, then what do? What does it mean? It means you're doing this minus A minus B. You're picking two numbers and you're removing them, right? But then you're adding two numbers, I mean the same thing, and you're doing this. What does it mean? It means the sum has decreased by 1. right? Whatever this was, the number is not important. In this case, it is S naught minus 1. It has decreased by 1 is the point. So is this not rigorous? Because my argument is not based off what two numbers you're picking and what are, it's just based on the steps, that at each step I've told you something happens no matter what is the nature of the step. So is everybody fine? Okay, I should have asked you guys more because this was a homework. But anyways, doesn't matter. Has everybody understood this, or rather does everybody agree with this? Okay, and that's good, right? Yeah, but this was, so you see the crispness of this explanation. Okay, and these are the explanations that you have to come up with. That is the nature of it. Okay, because as I said, this is one part of having invariance principle, pigeonhole principle. It allows you to say things rigorously. Okay, uh, so you're capturing some simple string in a complicated thing, and based off of that, you're giving a simple explanation, because that knowing about the string is enough. And here that was the summation. Okay, so this is, you see, what I have done here is I've constructed an invariant, a mathematical invariant. It's kind of not invariant, it's a monovariant. It is monotonically decreasing, but you understand the fact that it is decreasing by 1 is invariant. So this was simple, but yeah. So their explanation is also similar. Yeah, if the sum of the numbers except a and b equal to s, then the transformation decreases by n after n steps. Yeah, I've just explained it on step-by-step basis. I guess that's same. Okay, so I'm not going into it's fine. Okay, but since we are at it, let's actually do the next question, which is also Blackboard type. I expected you guys would try this also. So let's do this. So the theme of today, I have a slightly different theme in mind, but so we have another game of numbers on a Blackboard. Let's see what this is. So problem 2 maybe. Okay, so I don't know the question, so let me see. 1 to 20, and again you can take two numbers, you can erase them, but you have to replace them by ab plus a plus b. So this time it looks more strange. Okay, 1 2 3 dot 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 till 20. Let's write it. Okay, pick any two, pick any a comma b, replace okay. A question is, what is left in the end? So if anybody has done this, or even if you have read the solution, understood, you should try explaining it, because that is, so yeah, if anyone just anything, if anyone has an explanation or an answer. I have no idea right now, I have to think. But if anyone has, you should say. So at least you should know the answer. Yeah, you should may not be able to explain the answer, but you should know what the answer should be. Because you know that there is one answer. Let's say that there is one answer, and you should be able to explain it. Sorry, you should be able to find the answer. That should not be very difficult. So no one has tried this. Let's see. So if you have 1, 2, 3, 4 and you try this, then what do you get? You get, so let's say that I just pick the numbers from left to right. Okay, so I pick 1 and 2, I get 1 plus 2, 1 times 2. Okay, then I pick this and I pick 3. What do? I add them. So I do 1 plus 2 plus 3 plus 1 into 2 plus, what's the next thing? So the next thing I have to do is I have to take this number and I have to multiply it with 3. Is that okay with everyone? Let me just write that. But it's fine, but let me write it. 3 and then 4. Yeah, so then at this stage, this is your A. Okay, this is your B. And you've just said, right? So you're going to add them. You're going to add these two. So I'm just rearranging it and I get this. And then you have to multiply them. So if you multiply them, something interesting happens. You get 1 into 3. You get 2 into 3. And you get 1 into 2 into 3 plus 4. So you see what kind of thing you are getting. Is that coming to light? Is it coming to light? What kind of thing I'm going to get in the final step? So you just look at the second, this step itself. Right? So what do you have? So if you, or let's just look at this step itself. Just the first step, basically. If you forget about these two numbers, and what do you have? You have 1 and 2. You have all possible summations and products. Right? So you have sum of all possible products. Right? You have 1 and 2 lone, then you have 1 times 2. Okay. Similarly, when you come to the next step, and these expressions are incredibly useful in algebra and this throughout, because these expressions keep popping up everywhere. For you see, you get some of the numbers, then you can take the numbers 2 at a time, 1 and 2, 1 and 3, 2 and 3, and then you add them. Then you take 3 at a time, so you take all 3. That's three of them only. You see, so with this, what do you think you're going to get next? You can work it out and tell me, or any way you can predict, you can tell. What are you going to get in the final step? That's right. Yeah. And 3 at a time also. Yeah. So yeah, so that's right. So there'll be a lot of expressions. So that is there, and 1 into 4. Then you have 2 into 3 plus 2 into 4. And let's write it since. Okay. Then there will be 3 at a time. Okay. So let's write it 1 into 2 into 3 plus 1 into 2 into 4 plus 2 into 3 into 4. And then there will be 4 at a time, which is a product of all. Yeah, it's a strange number, but okay, whatever. It's not strange, but so this is 3 at a time, and this is 4 at a time. So the basic question is like, is this pattern clear where this is going? If you add more numbers, yeah, is the pattern making sense to everyone? Okay, right. Yeah. Okay, Pragadish, is it okay to you also? Okay, okay. So Unab, you have just joined. So do you understand the pattern? So you guys can think of why this pattern is, and how do you sum this? Yeah, and why will this pattern always come up? Yeah, Unab, is this Are you understanding? Or yes. That's fine, but do you understand this? Like, so what we are doing is we have the numbers from, let's just say we have numbers 1, 2, 3, 4, and the here, so we are just picking numbers in the order from left to right, and we are picking the two numbers, the two leftmost numbers, we are adding them and then multiplying them. Okay, so if you do it in the first step, then do you see you get this? So you add 1 and 2 and then you multiply it. Okay, now this becomes your new number and this is 3, and then you do the same there. You add them and multiply. So notice how I did not do the calculations in the beginning. If you would have done the calculations, then you would have lost the pattern. So does everybody see that? I didn't. So if you calculate it out, then that's actually a loss. So this is a very important point, that you shouldn't just calculate things at each step, because that's a habit, especially the younger grades, we tend to do that all the time. So this is the thing. So the question is, so there are two questions from here, right? What are the two questions? Is why would you always get this pattern, and how do you sum this pattern? How do you sum this pattern? Let's not get into that now. The question is why would you always get the same answer? Just think for think for 1, 2, 3, 4. Okay, why would you always get the same answer? So you understand the answer, not just this big expression, but you understand what it is. Sum of the numbers, then I take the products 2 at a time, add them, 3 at a time, add them, and then all of them, and then add all. So you understand the answer. Why would you get this answer always? Always get the same answer. That is the first thing to think. Any rough explanation, because you have to really think this yourself. If your phone numbers, if I do it in a different order, do it yourself and see why will you end up with the same expression, not just the same answer, right? More than that, the answer would become coming in the same form in the end. That's not like, no, that's not, no. Even if that was the reason, it is not clear, right? Seems to be no obvious connection. And that is not, the reason is more than that. Certainly associative is needed, but no. So I would say that there is something about just one thing that I'm just thinking, right? There is something about this answer that tells you that the order does not matter. Do you guys get this feeling at least? Just this, like, I don't know an explanation. I'm not giving an explanation, and I don't even have a clear explanation. But there is, just look at the nature of the answer. Isn't it something? It seems something universal. highly symmetric expression, right? So does everybody feel that? It's about the nature of the answer will kind of make you sure that this has to be the answer no matter how you do it. And these are important aspects. These are the, because when you see symmetric expressions and so others, do you at least agree with me to some degree? Okay, so my point is that the nature, so let me say it in a slightly different way. If you look at the final answer, okay, and wherever you see 2 in the final answer, replace it by, make it 4. And whenever you see 4 in the final answer, replace it by 2. Does anything change? No, right? If you replace 2 and 4 and you swap them, make this 4, make this 2, make this 4, and where you had the, yeah, so this 2 and 4 will become 4 and 2, make this 2. You see, nothing changes. Nothing changes. I'll connect it with, but you see, even here you do it, even in each of those chunks, right? Nothing changes. Yeah, if you change the way things, change the role of the places, the answer doesn't change. What does it mean? It means that the order in which you did, like, because like if you got, so if let's say, I mean, if I got this answer, so if the order was that I first chose 1 and 2, then I chose 3, and then I chose, so I first chose 1 and 2, I took their answer, then I chose 3 and combined it, I took their answer, I combined with 4. If I did that and I got this answer, then if I make the order 1 and 4, I first pick 1 and 4, then I take the answer, I combine it with 3, I take the answer and I combine it with 2. If I did this order, first order, this, if I did my calculation in this order and I got this answer, which you see, then if I do the calculation in this order, then the role of 4 and 2 should switch. Do you guys agree, right? If I do this, then the answer should be 1 plus 4 plus 3 plus 2. And similarly, in other places, 1 and 4 will get, will swap. So this is a slightly, maybe it is a concept to try to understand. The answer can be said in a more, some trick I can tell, and you can see the answer also. But this is the core of the explanation, kind of. And then the other, they don't change. So if you change the order, then this should be the answer, but this answer is the same. Does everybody relate to this? Okay. Pragdish, do you see this? Please say. You have to think, yeah, everybody, please ask me, okay? If you don't understand, you have to think what you really don't understand, because it's not hard, it's impossible for me to know. It's an online class, right? I can't see. And okay, so you have to be honest and you have to ask yourself. And Nagesh, I think, yes, one thing. Yeah. Nagesh, I think maybe, do you mean commutativity? I don't know. I don't know. Did you mean A plus B is same as B plus A? That is the reason. Because after the explanation, I'm thinking that, yes, so that is certainly the core. That is certainly on one level the reason. Like if this was some other class, I would have just said commutativity is the hint. Okay, I can't say that here. I have this, but just saying commutativity also is not a, yeah, you understand this, or some other explanation has to be given. But yeah, really, it's about that 1 plus 2 is same as 2 plus 1. That is the reason for all this. Okay. Yes. So Ishana, you had a question. Yes, yes. In fact, what I have done is also algebraic, because you see, I have not done any calculations. I've never used, wherever used the fact that 1 plus 2 is 3. No, I have not, right? So I've also done the same thing as you have done, but yeah, you have to write A plus B, A, B, C in an exam. Otherwise, they will say you don't know it. But yeah, you see, I've only done algebra. So you should also appreciate from here the importance of algebra. Yeah, I mean, one can tell you that algebra proves, because it's a variable, it proves about infinitely many numbers in one shot. One can say and you can understand, but you can't relate. Maybe here you can relate that doing it algebra and do not doing the calculations. Basically, I've been doing it algebra means not doing the calculations. That is the crux of everything. Of to really see patterns, because patterns is all about something that holds for different numbers. So calculations don't tell you that all the time, obviously. But yeah. Okay, so the nature of the answer is such that it doesn't change when you do it in a different, because so you can just say that, I mean, this is what that the answer you're getting is a symmetric expression. And so if you do it in a different order, it, then if you do it in a different, if you change the order in which you do, then you change that order in the final answer, but the answer then doesn't change because it's symmetric. Yeah, the expressions are of that nature, that when you change some variables, swap some variables, things like that, then yeah, okay. But I'll try to give a better explanation, but or maybe let me not give, let me give you guys think of a better explanation, just like last day's question. Is that better, right? I shouldn't just keep talking, that's not good. Yeah, so you have to think now. There are better explanations which you can give. Okay. Yeah, I feel secure because I can think of a better explanation. Though I feel bad if when I can't think of an explanation, I just say to you, do it. But I can think of one now. That makes me feel confident. Anyways, so yeah. But I hope you like this question. This is the nature of this book. It has wonderful questions in this type. Okay. Yeah. So this is a homework you have to think. Okay, think of a better answer. Think of a better explanation. Because the explanation I've given is not incorrect, but it's hard to explain and write. It's a yeah, explanation. And you should spend some time thinking about it, maybe 10-15 minutes at least. And then you should, if you feel completely stuck, you can ask me. But if you want, you can also try to read the solution, but then you should explain it to me next time. Then that's really you, then only you can say you've understood. Otherwise you don't know whether you've understood. Okay, so if you read the solution, find a solution anywhere, ask anyone, ask me, but you have to explain it to me next time, next class. Okay, that's important to all of us. So should I move on to other things? Okay, we're spending a bit of time, but you can see all this still just when you do more maths, you'll see how these things come in. It's very it's just how it is, universal. Okay, so now I want to do this arrangements question. So there was this arrangement question. These are actual arrangement questions. So we had numbers and we did some operations, but now we have arrangement of objects. Okay, so I'll try to do 2 questions of that nature. Okay, arrangements. Yeah, I see the screen is just shaking constantly. I don't know what happened to this. Arrangement of, actually a different place, but arrangement of objects. Okay, so this question you may have seen is somewhat like this. There are 6 sectors. So I have to constantly refer to the question. So there is 6. Okay, 6 sectors. And we have some cones. Yeah, cones are kept in the sectors. And at each step, Yeah, at each step, you are allowed to pick two cones or two pawns, and you have to move them to the bordering sectors. Move those to sectors bordering those they stand on at the moment. So there is a lot of freedom. So what I'm saying is, but not one, you have to choose two of them. Okay, that's important. So at each step, so choosing two of them is important. Otherwise, this problem is trivial. Yeah? So each step, choose any two cones, yeah, and move them to bordering sectors. So what do I mean? Suppose you pick this cone and you pick this cone. Let's see, yeah. Then bordering sectors would mean you can move it to any two. Yeah, so for the first cone that I've selected, you can move it, you can either move it here, or you could even move it to the next to the other one here. But let's say you move it there. Choose this other cone, you can also move it, it's up to you. So you can move it this side. So when you do this, then what do you get? You will get something like this. So you will have two of them here, one, and is it correct? Yeah. Choose two cones and move them to bordering sectors. Adjacent is better, yeah. Yes, in the book it's bordering, it was also confusing to me. Adjacent is just simple, adjacent sectors. Or rather the sectors bordering them, adjacent sectors. So this is the, okay. Again, the question is, the nature of these questions is, can all the cones be can all the cones be collected in one sector? Yeah. So, I mean, the answer should be no, probably. I don't know. But I don't know how to do this. Let's think. I don't know. Yeah. Let me see the question. Yeah, that's a good question. It is allowed to shift any two pawns to bordering sectors, to sectors bordering those stand on. Yeah, I think that's allowed by the question. Yeah. And I said, yeah, choose any two cones, so you can, it's allowed. So that's allowed, yeah. And that's a good question, because I mean, if let's say, I mean, if you can end up with every sector having two cones or no cones, you should try it in the same way. Yeah, if you can end up with every sector having two cones or no cones, then also job is done. Is that right? This, if you can reach here, then from here you can certainly reach all cones in one sector. Do you guys see that? Yeah, does everybody see that? Because then, as she just said, you can pick these two and you can apply the rule, right? You can move it here, you can. So yeah, So this is the, so you see the graph of these configurations. There are several configurations, and yeah. So if you can show that you can't do this, then all that's also good enough. Or yeah, just think. Let's think. Yeah, right. Because you see, you can also go from here to here. Do you guys see that? Yeah. In fact, any two moves or any move is reversible. That's just maybe a useless observation, but that's correct. Yeah. Any move is reversible. Just do the opposite. Yeah. I mean, like if this is the new guy that came in, this is the new guy, just choose them and just reverse them. Any move is reversible, right? Also, yeah, it's possible, right? You mean you can end up with everything in the same cone, same sector? Okay. Okay, so let me just write yes here. I suppose this is fine, but that's not even important here. So, okay, so how do you do that? Sorry? Uh, huh? No, but do you get this? Did you get this? You mean every sector has two cones? Okay, how do you get that? Let's name the sectors. Okay, same name for all. Okay, then. Uh-huh. Okay. Yeah, certainly. Yeah, that's correct. Uh, yeah, that's right. That's uh, so then yeah, that's correct. That's certainly correct. Yeah, okay. But then so I have misread the question. Yeah, that is probably what is I have misunderstood. So they say in the question, they say there's a circle is divided into 6 sectors and a pawn stands in each of them. It is allowed to shift any 2 pawns to sectors bordering those they stand on. So the question is not very clear, right? I mean, we are not wrong if in this interpretation, right? Evela, we can do this, yeah. So yeah, but that certainly defeats the purpose of the question. So let us then assume, yeah, let's do that. Otherwise, we have not done anything. But oh, it's not working once again. No. Okay. So let us then assume that we are not allowed to choose two cones from the same sector. Okay. Let's assume that. So this is okay. This is correct, but yeah. Okay. So let's keep that. There's no problem in that. So not allowed to choose two cones from the same sector. Otherwise, this is possible. So now is it possible? Yeah, now it looks impossible, right? So how do you explain this? So you are saying that, and that's the point, and you have taken exactly the complement of this. Yeah. So you are saying that it is not possible to have um, one. So it is. So you are saying that always there will be one cone alone, one alone cone. That's a much stronger statement, but that also looks correct. So let me write that, and then we can think of it. So this is a very interesting claim, and this will do the problem. There will always be a lone cone. Okay. So then since two people say it's true, let's keep this for homework, and then you guys can try to explain this. Very good. So people are making progress. The ideas are coming up today. Yeah. So please explain this for homework. Everybody okay? Or you think of another way to also do it. You can just think now. I don't want an answer from anyone now, but you can just think if you want. But yeah, think this carefully and write. And always please write. Okay. It's not mandatory that you show it to me, but everybody, okay? Right. Because see, some people may be better at getting the solutions quickly. Some may not be naturally that fast at it. But there are certain things that all of us can do and catch up or not, whatever. That is the point. But you should, all of us, you can write. Write and write. Okay. When you think of some solution, try to write it. Try to, if you like writing, okay, and then you can just send it to me. Just click a picture, send it. You can do that, okay? And that is very important, okay? So everybody should do this, okay? At least sometimes I should see some things written in from you, because I'm writing always right on the board. I don't know what you guys are doing. It's not mandatory, because this is not like, you know, you are students and this sir and writing. No, it's not, because you are doing this out of your own, you know, liking for it, most like, I suppose. It's fine, but still you should write in, because then you see you'll improve. Because I'm not very good at problem solving, but you see I used to write a lot and I still write a lot, and that's why I have this, I can explain things, you know, that I think that I can do a good way. I'm not very good at solving problems, but okay, I'm not trying that much also, but I'm trying whatever. But you see, writing, so that helps me to think, and so I'm good at theoretical things a little bit more. Okay, so okay, so that's what. Yeah, so try to write and send it. That way also you'll improve a lot, and also writing well will give you an edge in the exams. Okay, let's do a similar question then. This is about some sparrows. I was looking at this question, and maybe we can do this. Where is the question? Okay. Yeah, sorry. So this is another arrangement question. Okay, another. So start writing will help you very much in the exams. Okay, and much beyond that, but right. Another arrangement problem. Okay. So what is this question? So there are so there is a no, track or something, and there are six poles, and there are sparrows. Yeah, so there are 6 sparrows. So gonna draw 6 sparrows. Yeah, but 6 sparrows. Okay. So this is the situation you begin with. Now the thing is that at each step, at each, okay, I hope you guys have seen and tried these questions. Okay, but either ways, at each step, not a problem if you haven't. At each step, one sparrow moves from one pole to another, and another sparrow moves the same amount, so in the opposite direction. Okay, so what this means is simple. If suppose in first move, the first sparrow goes from here to here, so he is, well, distance you can just count by skipping, so he skips one pole. Then it means that there will be another sparrow, which don't know which one. Okay, but some sparrow, let's say this one in this case, will move like this. Yeah, it will move from one pole to the other and the same. Okay, this means that now there will be 2 sparrows here. Yeah, there's already a sparrow here. Yeah, and then there is another one. 2 sparrows. Okay, so that's what. And then this pole becomes empty. Just the natural things. Yeah, maybe not such a good diagram for this question. The question is it possible that all sparrows end up on the same pole? Okay, think about this. I will just come. Okay, just think. Okay. So anyone else?
No, sir, it wouldn't be possible to do this.
Okay. Why? Hmm. Yeah. So why? So where? So there's a gap in there, right? Six. So if there are six poles, so why does that? Uh-huh. Yes, that is, yeah. But then why in an even number of poles they cannot? No, circular is a, yeah, I don't know. But yeah, I don't, that these are all little vague, right? Because when you say that, so they don't swap in that sense, right? Because it could come like this and like this could also come like this. This, then you have three in the same pole. Uh, you see, there is a little, because the other sparrow can move from some other pole, moves by the same amount, but he can start from some other pole, some uh, same. But why? Yeah, that is yeah. So you're saying that's the best you can do. That is possible. But then why is that an obstruction or a reason? Yes, that's right. In fact, that is the next part. Yeah. So That's right. So for odd number, it is certainly possible. And you can, as you've said, as others have also said, kind of, that, yeah, in odd number of poles, it is possible. You can make them all meet in the center. Same moves they made, again, same moves, same amount of moves, and again, same amount. Yeah, it's fine. But for even number, why you cannot do, I don't find because when you're giving an explanation, right, you have to logically move. So you can come up with explanation in a flash that we don't know how you one comes up with that. But then you have to the logical steps that go from your explanation to the final answer, there should be simple logical steps that anyone should be able to understand. That I see missing in you guys' explanations, right? Pragadish, do you have any explanation in this case? Why this is not possible in the even case? Any? Uh, yeah, again, so that's right. So that's the intuition that all others are also kind of saying, but it's an incomplete explanation, right? Because, yeah, incomplete. So I see different attempts, and all of them are roughly saying the same thing, but so you have to set up an invariant, kind of. Then you can say this surely. Yeah. So there is not yet any good explanation. So is there anything that is not changing when so can you find a quantity which is not changing when you make the move? Yeah. So find a quantity that is not changing upon a move uh, during a step. So think of one step at a time. That's the point of invariance principle. And find out something that is not changing. This moving in the right direction and someone moving in the left direction. So you can't say that it's remaining balanced, right? Because it's not remaining balanced. Yeah. So in that way, things are changing. But you have to find something more general, which is not changing. Right. So it is something like, you see, when I take numbers from 1 to 10 and I add 1 to, yeah, yeah, yeah. Hmm. So you're saying the number of steps are the same. That's right. But that's almost what is given in the question. That's what's given. Number of steps to the right and to the left. Total sum. Yeah. So if you say something, yeah, that's the thing. You see, it's total sum, because otherwise there is no quantity. There is not, but sum. What is that sum? What is the initial sum? Yeah. What is the initial sum? What should we take as the initial sum? See, if you just say that in each move there are equal number of right or left moves, that's true. But if you take right moves as adding, less moves as subtracting, then what does not change? What is a quantity that you can start with and then say that, look, this quantity is not changing? we are subtracting, it is always 0. What do you mean? No, so yeah. Yeah, that's right. That's right. But that's what is just given in the question. But then you have to find a quantity that you can start with, and that doesn't change. You have to find something more universal that takes into account everything. Just like I was going to say, so if you have numbers from 1 to 10 and you add 1 to each, then that set changes, right? The set becomes 2 to 11, right? But if you take the whole natural numbers and you add 1 to each, okay, if you take the integers and add 1 to each, then the integers remain integers, right? That there's you don't lose any integers if you add 1 to each integer. So you see, right? So some extra symmetry in that structure or some globalness in the structure allows for more cancellations and something doesn't change. So my point is that here, if this is going 2 steps to the right, then I'll add 2, but I'll add 2 to the what? I can add 2 to the position of the sparrow, right? And that's the right way to say, right? Because then you have a clear way. So what I'm saying is that initially I can say this is pole 1, so number the poles. So it is similar to the question last time, but last question, we got a slightly different explanation also, which is, I suppose, correct. You guys can explain it. 1 to 6. So this is the number of the poles, right? Now the point is that at each step, no, so what I'm saying is that you take the sparrow that is in the first, so sum of the positions, yeah, sum of the positions, sum of the ranks of positions, this position, some of the positions, yeah. What is it initially? Initially, it is that in position 1 there is a sparrow. So this sparrow that is maybe so there is this sparrow. Yeah, this sparrow has position 1, right? So sparrow has position 1, then there is another sparrow here, so he has position 2, and so on and so on. So the total position, the total sum of the positions is 1 up to 6, yeah, and that is 6 into 7 by 2. Whatever, that doesn't matter. What happens? So can you show that this doesn't change after a move? This quantity. So you see what this quantity is, right? For each sparrow, I'm taking his or her position. I'm taking the sparrow's position and I'm noting it down. I'm adding all the positions. So what happens that when you make a move, you have two sparrows move in equal directions and move in equal amounts in opposite directions. Explain what? Yeah, so I've described an invariant. Yeah. Can anybody explain what this invariant is? I've described a quantity. So what is this quantity? Please try to explain, someone. Like, what is this quantity doing? So given any arrangement of sparrows, for each sparrow, I am noting down its position. Yeah. For each sparrow, note down its position, which pole number it is in, and add the pole numbers that you get in this way. Yes. So yeah. So firstly, that is what the value is standing for. So let me just give another example and explain this. Okay. So suppose that you have, just for fun, suppose you have two sparrows here, one here, no sparrows here, three sparrows here, and so then no sparrows. Okay. Then what will the sum be? Can anybody just say this quickly? For this particular, let's just imagine, right? If this was the situation, what sum will it give according to our rule? Um, no, don't go by, okay. I mean, are you sure? Because I've just randomly put this may not even be possible. No. So see, so these two sparrows are in position one, right? So they will have this. There is a sparrow with position two. So one sparrow, position two. Then there are three sparrows in position four. Or for each sparrow, you could write a four. I mean, you may still get the same answer, but the rule is this. Okay. So 2 plus 2, both is at 12. You get 16. So I don't know if that is the same answer, but it's not the same answer. But yeah. So I mean, this will not be possible. I mean, this particular arrangement will not be possible. That is a different thing. But just to understand what the rule is, for each sparrow, write down its rank, write down its pole number. Is the rule for the summation clear? Yeah. If it's not, then tell me, take another example and try. Okay. So then let's move on. So now we want to say that this quantity, we want to show that this quantity does not change. Yeah, that's what we want to show. So that's what we need to explain. So initially we had one sparrow each. So why will this quantity not change? So you must understand what the quantity is, what it is trying, what it is doing. And now, why will this not change? Yeah, so that is just the thing I kind of, you can say that I just came up with this thing. It is just the rule, right? So it is just a quantity I came up with, right? A rule that I come up with that I'll just consider. So I'm considering this quantity because this is a quantity that seems like it will not change. Okay. Yeah, you see, this is the quantity that seems like it will not change because we were trying to capture this, that you're moving 2 steps to the right, some sparrow is moving, there'll be another sparrow that moves 2 steps to the left. We want to say something doesn't change. Okay, so the position of some every sparrow is changing. You cannot say that there is some balance that is being maintained because you see those two sparrows could start from very different places and they could, yeah. But this quantity is the right quantity because this kind of takes everything into account. Yeah, so this is just a construction. Now we want to say this doesn't change. Yeah, so why is it that it doesn't change? So someone should explain this. Yeah. Think. So you make a move and see what happens to this expression. Yeah, take any two sparrows and you move them and see what happens to the resulting expression. That will tell you maybe why it is not changing. Yeah. So let's see. I mean, let's see what happens with the expression. So let's say that I pick two sparrows. So I pick this sparrow and just pick any other sparrow. So you can pick this sparrow. Okay. So I move, let's say I move this here and I have to move this here. So how is the summation affected? Okay. So, well, this first sparrow in the first position that remains as it is. Yeah. Now in the second pole, there is no sparrow. Yeah. In the third pole, there are two sparrows. Well, that's one way to see it. Another way to see is that this sparrow, his position increases by one, right? So that two will get added by one. So there was a two initially, but now he's gone to three. But then there is another sparrow whose position has come down. And so he was at six, six becomes five. There's a plus one here, but then the six becomes five. The other things remain the same in the sense that there was this third sparrow, which was already here, it remains there. So that will still contribute to three. And the fourth one remains where it is. And fifth one where it is. Another one has moved to the fifth one, but that's fine. That we have accommodated for. And that's it. This is what it is. Yeah. Your picture would now look like this. So, and we get the same summation, and it's not an accident. It happens in a very precise way. You see, I mean, this happening in a very precise way is the reason why this technique extends beyond numbers to many other things, because this is not about numbers. Yeah, it's not about the sum. It's about this very simple switch. Yeah, which applies to many things. So now does it make sense that now you can think of a very simple explanation why this is not changing. I have already said it somewhere, but yeah, does it feel more, yeah, correct to say that this doesn't change? Anyone? No? Hmm. Right. No, that's right. But initially, but you said that there are only three ways the sparrows can end up in. That needs a proof if you're going that way. Is that right? Uh, so what was your initial claim? Yes, but that needs a lot of working out because there are so many different ways, right? I mean, you see, right? I mean, to actually claim that, you have to, yeah, No, it is not mirror image. It's not mirror image because you see the point. Yeah, you understand. It's not, there's no mirror. It's like there's no mirror at 3.5 and it's happening. That is not what is happening, because you could have a sparrow moving from the first position to second position, and then a sparrow from the third position to the second position. So then the mirror is where at 2. The mirror keeps shifting in that way. You see, so there is a. It's not exactly like, you know, 2 sparrows are at symmetrical positions from the center and then they are moving. You know, that is not what is happening. Hey, you can see that. So that is why I'm skeptic of that. I mean, what you're saying may still be correct, but then you will have to do a lot of casework maybe and then get. And why are evenly distributed cases the only one? Why not some other 4 and 2 or something? Yeah, maybe that is not possible, but okay. Is that making sense? Yeah, yeah. Or if you can find an explanation as to why they are the only, or maybe then basically you will you have to end up finding all possible distributions, right? All possible distributions. That, because why only consider the evenly distributed ones? Yeah, why not find all possible distributions? Okay, that is the thing. Yeah, but then is this explanation understood, understandable? Okay, you see, this is just again same thing, like everybody is kind of feels the answer and has some sort of an explanation that you will write, but with this it is a clean argument. Okay, yeah. So what you guys can think is that class is over now. We just, you can think, what are all the possible distributions? It's a vague question, but it's a good question because there are several things you can say maybe. Okay, I'm just keeping it vague. You can make what you want of it and think, because it can be answered on several levels of detail. But what are all the possible, because I'm not just saying this just because I've asked this question and now generalizing. No, there is a different merit to this, you will see. But if you try this, then only I will say the next thing. If nobody tries it, then I will not say. Okay, so please try this. Okay, because again, we will learn something more if you do this. Yeah, not just an evenly distributed one, but just what are all the possible distributions. Okay, we try this, then something good will come. Otherwise, yeah. So yeah, try that. Yeah. So if there are no questions, then that's it. The main thing, yeah, are there any questions? Yes, some will be same. Okay, so sorry. So the problem is not done. So I have not just yeah. So please complete the problem. This is not yet done because I've only shown that this summation does not change. Yeah. So complete. Yeah. So this does not change. Now the point is that this summation is odd. This is an odd number. It's an odd number. Okay, it's an odd number. But if all the 6 sparrows end up at the same pole, then the summation will be even, right? Because if you can understand that, right? Because we don't know which pole and which thing, but well, that also, okay, you cannot say because there is no possible pole in that sense, but yeah, then the sum will be whatever pole they are at, k times 6, right? Each sparrow is at the same kth pole, it will be k times 6. That's an even number, but then it's an odd number. Okay, so try to explain this in detail, why the summation is not changing. I've given an example and said, but let's see if you can write it. It makes a big difference. If you cannot write it, then nobody knows that you know it in the exam. Okay, so try this and ask me next time that, yeah, I had trouble in writing this, or I could, or this is the thing, check it. Yeah. Yeah, for even number or odd numbers, you can see where the difference lies. So you can think, I mean, just this is up to you now. Take 7, 8, 9 and check what is happening. Yeah. for the odd numbers possible. Just think.